This demonstration will walk you through all of the applications in Aras Innovator to show how a single digital thread is constructed and managed for your product's design. Connectors to authoring tools throughout the lifecycle, like CAD, systems engineering, simulation, and even Microsoft Office, shown here, lets users work in familiar applications while managing changes, templates, review processes, collaboration, and links to part data, all in Aras Innovator. Here, we'll choose a template to start our new document and associate it with a part managed by the platform. Collaboration that happens here is managed by Aras Innovator, visible back on the platform to other users. Aras Innovator is built for collaboration with a secure discussion thread style user experience for comments and markup available to any user on the platform or in their native applications via connectors. This mobile application offers convenience and ease of use for on-the-go collaboration, a view into your tasks, PLM data, CAD viewables, and more. Tasks like engineering change order notifications are associated with their CAD documents for review and sign-off. Complete access to 3D visualizations with markup capabilities is available to all users, even those who don't have CAD software. The modern, fully featured browser-based client in Aras Innovator offers access to all the content we just added right here in the My Discussions area. In My Discussions, users can follow conversations, they can follow items like parts, and they can follow other users. They can even create forums just for discussion, and they receive notifications whenever their conversations are updated, ensuring visibility and collaboration during product development tasks without compromising on security or traceability the way typical email and chat do. You can search your discussions and click right on the item associated with each discussion you find here. Let's look at the product engineering application first. Every item in Aras Innovator includes a form view at the top with its complete metadata, plus relationship tabs at the bottom to demonstrate critical associations with information from across the platform, like these documents associated with this part. Each document or CAD document represented by a viewable is found up here. In the browser version, this is where you view, markup, and comment on each attachment, just the way we saw in the mobile interface. For instance, we can find the document we just uploaded using the Microsoft Word connector and continue commenting on it. The user interface in Aras Innovator offers some very helpful experiences for personalization, efficiency, and productivity. The table of contents flies out or can remain pinned. Personalize the sidebar here with your most used applications. The next level quick access panel offers quick and easy ways to search and create new items. It also holds your favorite or pinned items and offers predictive search for faster access. Easily favorite your most used items to pin them right here. You can also save favorite searches and access them here. With multiple tabs open, multitasking is easy. Click and drag them to the order you prefer working in. Personalize your user experience further with save searches and save grid layouts that persist every time you search in that item type. Personalizing the user experience in each session you work in is possible with split screen mode. Just dock and undock tabs to work interactively across the panes for flexibility and ease of use. You can see everything you need right here in one place. Another highly visual feature that makes it possible to navigate CAD and PLM data together in context is dynamic product navigation. Customize one or many views of the PLM data associated with these CAD parts using a shattered approach to constructing the viewable. Each view runs a dynamic query that assembles current PLM data about the CAD parts right alongside the parts themselves. Select a CAD part to view its PLM data, like problem reports, documents, requirements, and more, with a live link to drill down right to those items. All of a part's related items are visible here from the item form in the Structure browser. And where is this part a related item throughout the platform? You can see in the Where Used interface. For instance, we can tell that the item is a part of a change process. You can see exactly which one right here. You can also see the problem report we just checked out and the corrective action plan used to correct the issue uncovered by that problem report. Quality management in Aras Innovator organizes all of the steps in a corrective action plan right here, including related events like problem reports and nonconformances. It manages actions taken to contain them, like purge, hold, and stop ship notices. And it manages the root cause analysis step that helped lead to this corrective action. Here, the cause of the overheating problem was found to be a low-performance fan. It was found using a 5 whys root cause analysis process. Corrective and preventive actions are managed here too, like this new fan supplier and the ECO and updated design quality document indicated for preventing this issue from recurring. Quality planning in Aras Innovator offers both design and process quality methods. Starting in the design quality document, we can see how a standard FMEA format, that is, failure mode and effects analysis, is available to analyze, catalog, and mitigate risks across a product's design. In fact, the cause we just flagged in the CAPA can be added here to the design FMEA to ensure a low-performance fan is not used again with this extruder. Next, this link between the corrective action plan and the engineering change order creates an auditable record to demonstrate that the issue was addressed and corrected during the product development process. Let's look next at an engineering change process in Aras Innovator. The engineering change order keeps a record of every item impacted by the change, and it can include subordinate changes, like document change orders, that can be set to release only upon release of the higher level change order. Columns in this impact matrix indicate actions that will automatically be executed across the platform, like removing the old fan and adding the new fan. Our engineer is slated to sign off on this change, but before he does, he wants to check and be sure there are no other possible causes besides the faulty fan. Using the connection between the engineering change order and all the rest of the data across the Aras platform, he'll navigate this digital thread of information to check out the product's original design, starting all the way back at the requirements phase. He can find the requirements here on the viewable, but they're also linked to the part form, the where used action, and many other intrinsic links across the platform. The requirements engineering application you see here organizes requirements by documents, which roll up individual requirements all managed by the system into one continuous document. Whenever the document or the requirement is changed, the other reflects that change to ensure continuity. This requirement for the extruder temperature indicates that a uniform temperature must be maintained in each zone. This mechanical type requirement is fulfilled by a part, which, no surprise, is the extruder. To see if this design was digitally validated during simulation, we'll go check out the where used action for this part again. The simulation management application in Aras Innovator organizes a record of simulation inputs, instructions, and results into simulation studies. That is, sets of tasks denoting how to prepare the model for simulation, what variables to test for, and what viewables and reports were output as a result of running the study. Organizing them all in PLM ensures their traceability to parts and bill of materials information and keeps them in context with product changes to ensure that every change is validated. Plus, it keeps them visible to more engineers than just simulation engineers. It keeps CAD data used in those simulations associated with their simulation tasks and results. This ensures repeatability, no matter where in the lifecycle a simulation study needs to be repeated. This graphical view of a simulation study demonstrates the branching possible in the tool. But these are not just a pretty picture, they are live links to each task. Here, we'll select the final step in the process to see the simulation results. They include artifacts from the simulation tool where the study was executed. It looks like the original design held its temperature evenly across all the zones, meeting its requirements, and leaving our low-performing fan as the likely culprit. For validation, we can check that yes, indeed, the most recent versions of the CAD data were used in this study. And finally, external artifacts can also be attached, like this 3D visualization from the vCollab simulation rendering tool. We'll check out one more type of requirement to complete our trek through the digital thread of this product's information, the functional requirement for the extruder assembly, which indicates the design of a PID type temperature controller for the extruder part. Functional type requirements can be satisfied by functional elements in the system's architecture, also managed in Aras Innovator. Digital validation for the system element by way of simulation can also be linked here. This is a system-level simulation model authored in Simulink. The system architecture application connects a full functional structure with a logical structure comprised of system elements. These structures can be linked to requirements upstream, as we just saw, and parts downstream, which we'll see in a minute. The system architecture application is hierarchical in nature, and it can be derived from a system model authored in an external tool, in this case, MagicDraw. Viewables derived from this tool are available for markup and collaboration, making the system model more accessible to more users across the company for visibility, collaboration, and traceability when their work demands it. The graph navigation view you see here is enabled standard for many item types across the platform, like parts, simulation studies, and system architecture, which we'll look at here. A clear view of the relationships across the system model, its functional and logical elements, their child elements, and their related parts are all visible as you expand the graph. And this is live data. From here, you can open up each system element and part. In this step, we'll examine how two parts can fulfill one system element, the nozzle. The Bill of Materials Structure tab for the extruder part includes two nozzle parts, effective under different conditions for the same position in the bill of materials. This is known as part BOM effectivity, and it comes standard in the product engineering application, allowing for date, unit, and model effectivity, plus a range of new effectivities that your administrator can author and configure. Filtering on a condition like model lets you see only the nozzle that applies to the replicator model. And the same goes for unit and date, when these effectivity conditions are applied. You can also use all three together. Authoring and editing valid effectivity expressions is an easy and intuitive process. Back in the engineering change order, our engineer is now confident he wants to sign off on this ECO. Every task assigned to a user also appears in their in-basket. This offers a quick glance at where a task stands in its progress throughout its established workflow. Plus, it offers the user a chance to complete the task right here in their in-basket. Once our engineer signs off, then back on the ECO, we can see that it's been released and by whom, creating an auditable trail of this task throughout the system. Any sub-changes, like this document change order, are released upon approval as well. A fully featured reporting capability offers standard and customizable reports, like this ECO report tracking their status. Our engineer sees another change for which he'd like to track its progress, the second replicator model with the cover option. Up till now, we've seen many different ways to navigate this digital thread of product information all linked together across the system, but there's also a powerful enterprise search tool that offers free text search across every field and attachment on the platform. Parts managed in Aras Innovator can comprise mechanical, software, electrical, and electronic components. The component engineering application makes millions of source parts and their manufacturers available for users to search and select for use in their product's design. Manage your approved manufacturers and view their latest data sheets with a live connection to the IHS Markit Component Database. Search their components based on compliance requirements, plus a host of other features and characteristics to find just the one you need. Aras Innovator manages the entire scope of product development projects and programs from design and sourcing all the way out to their operational lifecycle. The program management application shown here hosts a project-level view of your products, personnel, and deliverables to track completeness against your goals. It offers a Gantt chart view to track your team's progress against stage gates and milestones, while linking directly to project deliverables across the system, like technical documents, parts, manufacturing process plans, and quality documents. This technical document demonstrates the links you can build between parts and other items across the Aras platform and the documentation that represents them. You can map part information to documents so that they're traceable elements that flag you as they change in other places across the system. You can decide whether to change the technical document to keep it up to date or leave it alone. This ensures your technical documentation is always in sync with the parts information they relate to. This project also manages a manufacturing process plan as one of its deliverables. The manufacturing process planning application in Aras Innovator, known as MPP, manages processes in hierarchical steps and operations. Each one of these is managed individually and can be linked to its associated parts for ease of reuse and traceability. As process plans are built, an associated MBOM, or manufacturing bill of materials, is constructed. Or you can start by constructing the MBOM and author process steps to accompany it. Both the MBOM and its associated process plan steps are constructed from parts in the EBOM for the product being manufactured. The two are kept in sync, as indicated by these overuse or underuse icons shown here, to ensure that the right parts and their quantities from the EBOM are consumed in the MBOM. The EBOM is visible right here, and it indicates which parts have not yet been consumed in the MBOM. To consume a part from the EBOM, the workbench in the MBOM gives the user full access to EBOM parts. Just click and drag the engineering part you need into its MBOM position. Back in the EBOM, you can see that the part has now been consumed. A corresponding process step will appear. We'll author that step next and demonstrate the traceability between process quality and manufacturing process planning in Aras Innovator. The process quality document can be synchronized with the manufacturing process plan so that when an MPP is updated with a new step, the process quality document, or PQD, flags the user to the change. This is because there might be a new risk to mitigate resulting from the new step. The process quality document manages a process FMEA, a process flow diagram, and a control plan, each synchronized to one another and to the manufacturing process plan. The quality engineer can choose to accept the new process step for the MPP to complete the process quality analysis using the updated information from the manufacturing team. This keeps the quality and manufacturing teams in sync. Aras Innovator manages your product's definition throughout its design, development, production, and operation. The Digital Twin Core application manages an accurate, up-to-date bill of materials for the physical product definition in the field as it evolves throughout service and maintenance. Each digital twin is connected with its released engineering part, so we can navigate from the engineering part to see all the physical products in the field. Likewise, we can navigate from the physical products in the field all the way back through its engineering history that we might need to know about. In turn, operational data from each digital twin in the field is available to the digital thread of information that began with requirements development and system modeling during the earliest concept design phases of engineering. Let's see how this works. From a digital twin of the MakerBot system, I can drill down to its component parts, like the body assembly, and record a maintenance event right here, like switching out this faulty stepper motor for a new one. I assign an end date for the motor, which automatically lets me choose a new physical part from either the same engineering part or a new one. Saving the new configuration shows me the new part at the same bill of materials position. But it's important to note here that the past part is saved in the operational history too. I can find this by changing the filter that assigns my view from current configuration of the digital twin to all, where I can see back in time to past digital twin configurations. I can even pick a point in time or a date range to view. Replacing a part brings its child parts along with it, so I can see here that these child parts were installed on the new assembly at a different point in the past. So there's a complete record here of this parent-child relationship for physical parts stored and traceable in the Digital Twin Core application. In this way, Aras Innovator manages every configuration of your products and systems designs, from early requirements through operational lifecycle, in a single, traceable digital thread of information.